Hello, everyone. Welcome back to another session with Dr. Anu Sidhu, who is a certified and licensed AP chemistry teacher. In the last session, Dr. Anu taught us about symbols of chemical elements in Dattle's atomic theory and the topic of chemical foundation, atoms, elements, and ions. And today we are going to continue that discussion. Dr. Anu, how are you?
Hello, Kamal. I'm not good. I'm very good today.
Oh, that's wonderful. That means that we are going to have another interesting session.
Yeah. Yes. I scared you by telling you that I'm not good today. I'm very good today. And I'm really excited to start with this session.
That's the kind of motivation that we need. Dr. Anu, in the last session, we discussed about Dattle's atomic theory. So please tell us more about it.
Okay, yeah. So Dalton's atomic theory is very fascinating. Actually, what I wanted to tell you is about the history behind that. No doubt there were 5 points about the Dalton's atomic theory. Look at the enthusiasm and the conviction of Dalton. Dalton being a school teacher, and he was so much convinced with his idea of this atomic theory. You won't believe that initially, just like any other ideas or theories, his theory was not accepted. It was like people were not ready to accept his theory of atomic, like this atomic theory. But he was convinced that he felt that he's right. So look at that intuition of a scientist, right? And later on, it was the scientists, they agreed upon that because there are a lot of experiments were done, and his Dalton, that this atomic theory was accepted, that atoms are the smallest particle of this matter, and atoms of different elements are different, atoms of same elements are same, and atoms, they combine the different elements, they combine to make complex compounds. So it is a widely accepted theory so far.
You use this word compound. What is a compound?
Yes. So like compound is very, very important. Why I'm stressing on this term is because we must know that compound is made up of atoms of elements, but it is the atoms of two or more different elements. It is never the atoms of the same element. So compound is always made up of the atoms of two or more different elements, and which are combined in a fixed ratio by mass. Like for example, water made up of hydrogen and oxygen, carbon dioxide made up of carbon and oxygen, sulfuric acid. Sulfuric acid is known as the king of chemicals, which is made up of hydrogen, sulfur, and oxygen. So we have sodium sulfate, like sodium, sulfur, and oxygen. We have sodium bicarbonate, which is also known as baking soda. So that is made up of sodium, hydrogen, carbon, oxygen. So like that. So you see, these are the atoms of different elements which are combining in a fixed ratio by mass. So that is known as the compounds.
So we've discussed about elements and compounds. So, Dr. Anu, what is meant by a chemical formula?
Yeah. So before coming to the chemical formula, I will give you a brief history about a little bit about the atoms right now. As I told you that Dalton's atomic theory is widely accepted, but later on there were certain discoveries they happened. It is about the discovery of fundamental particles, that is electrons, protons, neutrons, and apart from that, nucleus. So that changed that, and then later on, Dalton's atomic theory was discarded. So J.J. Thomson is a scientist who discovered electrons, and he got to know that the electrons are negatively charged particles. So he believed that if negative particles, like negatively charged particles, are inside the atom, definitely there should be something positive, so that the positive and negative, they should cancel out each other, because atom is a neutral particle as such, right? So the negative has to be neutralized by something which is positive. So there is a scientist with the name of E. Goldstein. He discovered protons, and protons are positively charged particles. So electrons are discovered by J.J. Thomson, and protons are discovered by this E. Goldstein. So J.J. Thomson, he proposed a model of atom that is known as the plum pudding model. It's very interesting. According to J.J. Thomson, what he said is that that protons are diffuse, they are spread out. Like positive charge is spread out just like a pudding, and electrons are embedded in that proton cloud, just like plums. Plums are embedded in that pudding. So you have to imagine that plums are like electrons, and then pudding is like protons. It is also known as watermelon model. Like in watermelon, red pulp, like you can imagine, you have to imagine that red pulp is like a proton cloud, like proton, and that black seeds which are in that watermelon, these are like electrons. So watermelon model or plum pudding model. So that was given by J.J. Thomson. And in the meantime, Rutherford. I have an interesting story about Rutherford. So Rutherford was born on a farm in New Zealand in around like 1895, long back ago, right? Yeah. And so he was a great scientist. He was interested in science and all that. And he was selected on the second position to get a scholarship from Cambridge University. So there was a first candidate, and then he was second. But somehow the first candidate got married. So he dropped the idea. The first candidate dropped the idea of going to get the scholarship. So Rutherford got that scholarship to go to that Cambridge University. So he was lucky. Yeah. So I really found this story very interesting about that fact about Rutherford. Yeah. So he discovered nucleus. We will go into the detail of discoveries later on. So it was whole coil scattering experiment, and he found that the nucleus is, I can say, it is a region in the center of the atom where the protons are located. So protons, in the meantime, neutrons were discovered by Chadwick. So another scientist, Chadwick, he discovered neutrons. So the neutrons and protons, they are located inside the nucleus, and nucleus is centrally placed. So whole of the mass of the atom is basically, it is inside the nucleus, that is protons and neutrons, because protons and neutrons have almost equal mass, but electrons have negligible mass. So this model, so Rutherford also tried to propose a model of atom. So that model is known as the solar system model. So just like solar system, we have sun in the middle, in the center, and planets are revolving in a fixed orbit. So similarly, in atom, the nucleus is in the center, and electrons are revolving around that nucleus in fixed circular path. But later on, you know what, it was again discarded. So there was a failure because nucleus has protons. Just imagine, protons are positive charged and electrons are negatively charged particles. And we all know that unlike charges, they attract each other, right? Yeah. So protons are positive, electrons are negative. It means the electrons should be attracted towards the nucleus. So while revolving, those electrons should bump inside the nucleus and the nucleus should collapse. But it never happens. Atoms are stable. So what are the various forces which are keeping the atom stable? Rutherford was not able to explain that. So later on, we have a lot many discoveries about what are the various forces which are keeping the atom stable. Yeah, so that is about the discoveries of fundamental particles and nucleus. Now coming back to this chemical formula, look, we have motivational speakers, right? Motivational speakers, they talk about success formulas, right? We have love formula, we have success formula, all those. So similarly in chemistry also, we have chemical formulas. So chemical formulas is the way we can represent chemical compounds. So what we do is two things. We have to use symbols of the elements. That's why I'm telling my students that it's very important to know the symbols of the elements. Yeah, so we use the symbols of the elements rather than writing the full name, and we use subscripts to write the number of atoms of that elements which make that compound. Like for example, if I give you this example that a compound contains 1 carbon and 2 oxygen. So now you know 1 carbon, 2 oxygen means C1O2. So you will write 1 and 2 as a subscript. So, but there is no need to write 1. So you will just write CO2, right? So like, for example, there is a compound which contains 6 carbons, 12 hydrogens, and 6 oxygen. So what will be the chemical formula? You will say C6H12O6. Simple, right? So if a compound contains 2 nitrogen atoms, 4 oxygen atoms, so you will say N2O4. So 2 and 4, they are as the subscript. So it's very easy to write the chemical formulas. I will go over the names also, that what is N2O4, it is called like dinitrogen tetroxide. So we will go over the naming, the rules. There are certain rules we need to follow to do the naming of the compounds. It's very easy to write the formulas once you know the number of atoms. So you have to write the symbols and the number of atoms as a subscript there.
With every session, it is getting just more interesting, and I'm so much fascinated by the amount of interest and passion that you have to teach chemistry. Dr. Anu, do you have any questions for your viewers today?
I just want to remind my students that please keep on learning about the symbols of the elements, and we will learn more about how to write the chemical formulas. But my main motivation here is that I want my students to learn from the basics, because my main philosophy is back to basics. Foundations really need to be very strong. Like for example, if we have to make any monument or any building, the foundation need to be strong. When the foundation is strong, then the building stays strong there, right? So same for the chemistry, for any subject, it is all about the strong foundations, and then we build up our knowledge on that strong foundation. So it is very, very important that the students, they open up their textbook, they learn more about that. And yes, I'm here to guide my students, to have sessions with them, to answer their questions. Yeah.
Thank you so much, Dr. Anu. Hope you guys learned and benefited from today's session. We will continue having these sessions for future for your better understanding and learning. Please like and subscribe to SIDHU'S Academy on YouTube.
Sorry about that.
Media signing off. Anything?
Yeah, I have just one thing to say today. Komal, I promise you today that I will never ever use sulfur, argon, calcium, and samarium with you. It means I will never use sarcasm with you. S for sulfur, AR for argon, Ca for calcium, and Sm for samarium. So never use sarcasm.
That was amazing. Please like and subscribe to SIDHU'S Academy on YouTube. This is Komal from the Outline Media signing off.